thing that's interesting about cosmic loneliness is that it's not really about being sad or depressed. It's about what we discover when we look at the universe carefully. And the universe has some surprising things to tell us if we're willing to listen. So let me start with something very simple, and then we'll build from there. Imagine you're out in a desert somewhere, and you look around. You see sand. You see maybe some rocks. The sun is overhead. It feels lonely, right? There's nobody around. But here's the thing. You're not actually alone. There's air around you. There are microbes in that air. If you dig down, there are bacteria in the soil. There's a whole invisible world of life happening all around you, even though you can't see it. Now take that feeling of the desert, but imagine it expanding infinitely in all directions. Not just around you, but in all directions, forever. That's more like what space actually is. It's vast. It's empty. And in that emptiness, something peculiar happens. When we look at the distances between objects in space, they're almost incomprehensible. Let me give you a sense of scale. The sun is about 150 million kilometers away from us. Light from the sun takes 8 minutes to reach us. 8 minutes. Now, the nearest star to our sun, not our sun, but the nearest star, is called Proxima Centauri. How far away is it? About 4.24 light years. Do you understand what that means? It means light, traveling at 300,000 kilometers per second, takes 4.24 years to get there. That's about 40 trillion kilometers. 40 trillion. Now, if you built a spaceship that could travel at the speed of light, which violates all the laws of physics we understand, but let's imagine it, it would still take you over 4 years just to reach the nearest star. And here's where it gets interesting. For most of human history, we didn't know any of this. We thought the stars were holes in a big dome. We thought they were just stuck on the side of a celestial sphere that rotated around us. That was fine. It was comfortable. We were at the center of everything. But then Copernicus came along and said, no, actually, we're not at the center. We're orbiting the sun. And people didn't like that very much. They really didn't. But the evidence was there, and eventually we had to accept it. But that was only the first blow. You see, even after we accepted that we orbit the sun, we still thought our sun was pretty special. We thought maybe it was at the center of the galaxy. Then we looked through better and better telescopes, and we found out that no, our sun is just an ordinary star, orbiting in the outer regions of something called the Milky Way galaxy. And the Milky Way is just one of hundreds of billions of galaxies. Hundreds of billions, each one with hundreds of billions of stars. And we're not even in the important part of our galaxy. We're way out on an arm, kind of in the suburbs. Now, you might think, well, there's so many stars and so many galaxies. Surely there must be life somewhere else. Surely we can't be alone. And that's a very reasonable thing to think. In fact, that's what most of us assumed for a long time. If there are that many places where life could arise, then of course life must have arisen in many of them, right? Well, let me tell you what we discovered when we actually started looking. In 1960, a scientist named Frank Drake started a project called SETI, Search for Extraterrestrial Intelligence. The idea was simple. We would point our radio telescopes at the stars and listen for radio signals coming from alien civilizations. It made sense. If there are advanced civilizations out there, they must be sending radio signals, right? We send radio signals, so they probably do too. We'd listen carefully, and we'd hear the cosmic background radiation, some natural radio noise from stars. But from civilizations? Nothing. Complete silence. Now, someone might say, maybe they're not using radio. Fair point. Maybe they're using some technology we haven't thought of. Maybe they're using light signals or gravitational waves or something else entirely. But here's the thing that bothered people about the silence. According to our best estimates, if life is reasonably common in the universe, we should have detected something by now. The fact that we haven't detected anything is what some people call the Fermi paradox. Enrico Fermi looked at this problem and said, if aliens are out there, where is everybody? It's a simple question, but it haunts us. Let me explain why the silence is so puzzling. Consider the timeline. The universe is about 13.8 billion years old. Our Earth is about 4.5 billion years old. Now, even if life only took 1 billion years to get started on some other planet, that still means civilizations have been developing for billions of years before us. Some of them should be millions of years ahead of us technologically. If they're millions of years ahead of us, They should be able to do things that seem like magic to us. They should be able to communicate across the galaxy easily. They should be everywhere. But they're not. Or if they are, they're not talking to us. This brings up one of the most interesting and disturbing possibilities. What if we're special? What if Earth is genuinely unusual in harboring life? What if intelligent life is vanishingly rare? Now, there are different ideas about why this might be true. One possibility is that the origin of life itself, abiogenesis, going from non-living chemistry to living cells, is incredibly unlikely. We don't know how it happened on Earth. We have some guesses. We think it probably involved some kind of chemistry in the oceans or in volcanic vents. RNA molecules self-replicating, proteins forming, membranes. But we don't actually know. It's possible that the exact conditions needed for life to begin are so specific, so improbable, that it almost never happens. It might have happened only once or twice in the entire observable universe. Or maybe life starts easily enough, but getting from simple life to complex, intelligent life is the hard part. After all, simple bacteria-like organisms dominated Earth for 3 billion years. 3 billion years of essentially the same primitive life. It wasn't until much later that complex multicellular life evolved. And even then, it took hundreds of millions more years before intelligent life appeared. Maybe that transition is incredibly rare. Maybe in most planets with life, life never gets past the bacterial stage. Now, there's another possibility we have to consider, and it's even more disturbing. What if advanced civilizations don't last very long? What if they develop technology and then destroy themselves? This is something called the Great Filter. The idea is that somewhere on the path from simple chemistry to advanced spacefaring civilization, there's a bottleneck, a filter, something that most life doesn't get past. Maybe it's that hard to get past transition to intelligent life. Or maybe it's that once you have intelligent life and technology, you develop weapons that destroy your civilization. Maybe every advanced civilization eventually wipes itself out. That would explain the silence. But whether it's the origin of life, or the evolution of intelligence, or the self-destruction of civilizations, the message is the same. We might be alone. Or if we're not alone, we're so incredibly far from anyone else that we might as well be. The nearest civilization, if one exists, might be thousands of light years away. Thousands. By the time we send a signal, even at the speed of light, it would take thousands of years to get there. And if we got a reply, it would take thousands of years to get back. We'd never have a conversation. It would be like leaving a message in a bottle and not expecting an answer for 6,000 years. It's possible, but it's not exactly the same as meeting someone. Now, let me tell you about something that happened in 1990 that really crystallized this feeling for a lot of people. There was a space probe called Voyager 1. It was launched in 1977 to explore the outer planets. By 1990, it had passed Neptune and was heading out into the interstellar void. And someone, a scientist named Carl Sagan, had the idea to turn the spacecraft's cameras around and take a picture of Earth. From 6 billion kilometers away, just a tiny picture. Do you know what Earth looks like from 6 billion kilometers away? It looks like a dot, a pale blue dot, suspended in a beam of light, less than a pixel. If you were looking at that image, you might not even notice Earth. You'd have to be told where to look. And when Sagan saw that image, he wrote something that's worth reading. He said, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. Every human being who ever lived. All of history, all of our achievements, all of our wars, all of our art, all of our music, all of our love stories. All of it happened on that pale blue dot. And when you look at a picture of that dot from that distance, something shifts in your mind. You realize how small we are. Not just small, but cosmically insignificant. We're not at the center of anything. We're not special in the way we thought we were. We're just here. Now, you might think that's depressing, and maybe it is, a little. But I want to tell you what I think is actually happening. I think what people are calling cosmic loneliness is really a kind of intellectual honesty. It's what happens when you actually look at the evidence and acknowledge what it's telling you. The universe is big. We don't know of any other life. We're far from any other civilization, if there is one. And that's just the truth of the situation. But here's what I find interesting. That truth doesn't have to be depressing. In fact, I think it's kind of wonderful. Let me explain why. If we are genuinely rare, if intelligent life on Earth is a statistical miracle, then we have an enormous responsibility. We have the responsibility of being the universe's way of knowing itself. Think about that for a moment. The universe is billions of years old. It contains unimaginable amounts of matter and energy, billions of galaxies, each with billions of stars. And in all of that vastness, there's only one place we know for certain where the universe has become conscious of itself, where the universe has looked up at the stars and asked questions about them. And that's here. That's us. That's not lonely in a sad way. That's lonely in the way an explorer is lonely. You're out there, you're investigating, you're trying to understand, and there's nobody else doing it in your area of space. But that doesn't mean your work is meaningless. It means it's important. It means you're important. Now, let me talk about some of the other things that contribute to this feeling of cosmic loneliness. There's something called cosmic voids. These are vast regions of space where there are almost no galaxies. Imagine an area of space millions of light years across where there are perhaps only a few dozen galaxies, when everywhere else has thousands. It's like the universe has holes in it, empty places, dead zones. A galaxy that happens to exist inside one of these voids would be extremely isolated. It would be surrounded by darkness in all directions. No nearby galaxies to interact with, no gravitational influences from neighbors, just alone. And here's something even stranger. As the universe expands, these voids are expanding faster than everywhere else. So the universe is becoming more empty, not less. The space between galaxies is getting bigger. The cosmic voids are getting bigger. In the future, billions of years from now, the universe will be even more lonely than it is now. But that's the physics. That's what's actually happening. There's also something we need to think about, which is the vast distances and the vast timescales involved. I said earlier that light from the nearest star takes 4.24 years to reach us. But do you know how long galaxies take to orbit each other? Or nebulae to form? Or stars to go through their full life cycle? We're talking billions of years. The human species has existed for about 300,000 years. Civilization has existed for maybe 10,000 years. Science as we know it has existed for maybe 500 years. And in all that time, we've developed radio. We've sent out our first radio signals. Those signals are traveling outward at the speed of light. But they've only gotten so far. Our first powerful radio transmissions were about 100 years ago. So our radio bubble is only about 100 light years across. There are billions of stars within 100 light years of us. But compared to the size of the galaxy, 100 light years is nothing. It's tiny. Think about what this means. To have a conversation with an advanced civilization at another star, both civilizations would have to exist at the same time, and they'd have to be powerful enough and lucky enough to pick up each other's signals, and they'd have to happen to be looking in the right direction at the right time. The odds are almost infinitesimal. It's possible, but barely. Now, there's a philosophical question that goes along with all of this, and I think it's worth considering. If we never find evidence of other intelligent life, what does that mean for us? What does that mean for the universe? Some people find this depressing. They think it means life is pointless. We're alone in a universe that doesn't care about us, and eventually we'll die, and everything will be forgotten. But I don't think that's the right conclusion. Here's what I think. If we are unique, if intelligent life is so rare that we might be alone, then that makes our existence more meaningful, not less. We are the universe examining itself. We are billions of atoms that have arranged themselves in such a way as to think about the universe and our place in it. That's extraordinary. That's remarkable. That's worth something. And I think it should make us think differently about Earth. If Earth is the only place we know of where life has arisen, then Earth is precious. It's not just some rock we live on. It's the jewel of the universe, the one place where this has happened. And what we do with this planet matters. What we choose to do with life on this planet, the choices we make about how we treat each other, how we treat other species, what kind of civilization we build. Those choices matter in a way that's almost hard to comprehend. There's also the question of responsibility. If we're possibly alone, then we have a responsibility to survive. We have a responsibility not to destroy ourselves. And we have a responsibility to preserve knowledge, to continue learning, to continue trying to understand the universe. Because if we're the universe's way of knowing itself, then that's important. That's what we should be doing. Now, I want to say something about the search for life. because this is still an active area of science. We haven't given up on finding evidence of life elsewhere. We have the James Webb Space Telescope now, which can look at the atmospheres of exoplanets, planets orbiting other stars, and it can look for chemical signs of life. If there are planets with oxygen-rich atmospheres that might indicate life, we've discovered thousands of exoplanets, and many of them are in the habitable zone, the region around a star where liquid water could exist. So it's not impossible that life exists elsewhere. We just haven't found it yet. But here's the thing. Even if we find microbial life on Mars, or find chemical signs of life in the atmosphere of an exoplanet, that doesn't really solve the core problem of cosmic loneliness. Because intelligent life is different. Microbial life isn't going to have a conversation with us. We're looking for other intelligent beings, other minds, and there's no evidence of that. Not yet. I think what cosmic loneliness really teaches us is something important about the nature of the universe and our place in it. It teaches us that we live in a cosmos that is vast beyond imagination, filled with billions of galaxies and trillions of stars. And despite all that, there's a profound silence. No other voices, no other minds that we know of, just us. And that's actually okay, because it means the job is ours. The job of exploring, of learning, of understanding, of creating meaning, of building civilization, of making art and music and science and love. Those are our jobs. We can't wait for someone else to show us how to do it. There is no one else. Not yet, anyway. Not that we know of. So when you think about cosmic loneliness, don't think of it as a sad thing. Think of it as a kind of freedom. Think of it as a responsibility. Think of it as a call to make something meaningful out of this strange situation we find ourselves in. We're conscious beings in a vast universe. We're the universe's way of knowing itself. And that's not lonely. That's profound. The universe is incredibly vast, and we're incredibly small. We're made of atoms that were forged in the hearts of dying stars. The carbon in our bodies, the oxygen we breathe, the calcium in our bones. All of it came from stars that exploded billions of years ago. We are made of stardust. We are a part of the universe examining itself. And yes, we might be alone, or we might not be. Maybe there's life everywhere, and we just haven't learned how to find it yet. Maybe there are thousands of intelligent civilizations in the galaxy, and they're all listening for us, just like we're listening for them. Maybe there's a great galactic conversation happening, and we're just not sophisticated enough to pick up the signal yet. It's possible, but even if we are alone, even if we never find another intelligent being in the universe, the story isn't over. It's just the beginning. We have billions of years ahead of us, assuming we don't destroy ourselves, and we have so much left to learn. Every question we answer about the universe opens up new questions. Every discovery we make shows us how much more there is to know. That's what I find beautiful about cosmic loneliness. It's not despair. It's not sadness. It's the recognition that we have work to do. We have mysteries to solve. We have the entire universe to explore, and we're the only ones doing it that we know of. So we'd better get to work. The pale blue dot, that's us. That's everything. And we have an enormous amount of work to do on it and around it. Isn't that worth doing?